When you go for a job interview, do you know what is the exact moment when you get rejected? When the person on the other side of the table decides that he or she is not going to take your profile forward. That moment is when that person gets a feeling that you don't know the basics, your foundation is weak. This is one common problem I am observing recently in many of the candidates. In this video, I am going to show you two ways by taking two of the use cases and tell you how can you build the foundational knowledge well so that these kind of rejections you will not face in interview. Let's see that with some examples. So let's take a couple of examples and try to understand how should you go about learning a particular topic in data science. Okay. Remember guys, this is pretty important for you if you are new to the field. So I'm going to take example of two complex topics. One is called PCA, another is called gradient descent. Okay. Suppose I want to learn about gradient descent and PCA, then what is my advised way of learning that? First of all, let's take gradient descent only. Okay. And what I will do is I will go to Google and search for some good articles, some good blogs, some good YouTube videos or anything like that. Okay. So for example, let me go here and try to give you a, if I go to YouTube and I search for gradient descent, then let's say I say unfold data science gradient descent, right? So I get this particular video. So as you can see, this video is having nearly 200K views. It must be having some good info. So you can watch this video and learn about this or any other video also. If you prefer to watch from other places, you can watch that. So what I'm saying is this is your step one, getting the fundamental knowledge. Once you get the fundamental knowledge, then I'm going to write here something. You must not do that. Don't jump don't jump to Python packages. Don't do that. Okay. I'm going to tell you why, and I'm going to give you a 4-step process of how you should learn a new topic. But remember, when you learn the fundamentals, when you are building your concepts, don't jump to Python packages. Then your next question will be what to do in this case, right? So let me show you by hands-on what you should do in this case. Now tell me, based on your understanding, you can think through in your mind, what do you think gradient descent does? I'm sure you must be having some idea of gradient descent, but let me write here. So gradient descent, if I have to, let's say, implement gradient descent, and what are the key things I need to implement gradient descent? So gradient descent is basically looking for a loss function, right? Loss function, okay? And gradient descent is looking for a parameters which it need to optimize. So parameters in this case, let me put weights or initial weights. Okay, weights to be optimized. Just a simple example here, weights to be optimized. Okay, what else gradient descent needs? Gradient descent needs iteration. Okay, so in multiple iteration, gradient descent will try to optimize this weight for that given loss function. This is part one of this story. So I'm trying to break it into pieces so that your concepts become clear and you know what I'm trying to convey here. Okay. This is part one of the story. Now, immediately what should come to your mind is, okay, for this loss function, I need two things. What are the two things you need for loss function? One is actual values, correct? Actual, or you can say truth. Okay. And other is predicted values, right? Predicted values. Then only there will be a loss function, right? Now, for actual and predicted values, what else do you need? So here, if you want to, let's say I can define some numbers in an array. For example, I can say 1, 2, 3, 4, 5. These are my actuals. But for prediction, I should either have a machine learning model or I should have a function written, which will tell me, okay, this is the prediction. Now, why I'm telling you all these things in detail is I'm going to show you in notebook now how I have built it from the scratch. Okay, so let me take you to the notebook here and try to show you the better learning process. So first of all, guys, if some of you don't know about JAX, 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 right? So JAX is a NumPy basically, but advanced NumPy you can say, that works well on the CPU, GPU, and TPU. Okay, with great automatic differentiation for high performance machine learning research. So you can use JAX. It is one kind of NumPy only, but faster and more efficient. Okay, so I'm using JAX in my example. Here I'm importing JAX NumPy, I'm importing random, and I'm importing PyPlot for some plotting. Don't bother, these are simple things. Now, as I told you, if you compare with my notebook, right, what I will need for defining my loss function, I will need the actuals. Okay, actuals. So let me go ahead and define my actual values. So you can see here, you can see here, here I am saying def truth. Def truth means I'm just, defining my truth values for different values of x, and I'm saying return x, to the power 3. So whatever value I give, it will give me cube of that. That's my actuals. Okay, I give x, it gives me 3 power of that. And here if you can see, I'm saying x train is equal to some numbers I'm taking. Okay, y train is equal to truth of x train. So just pay attention to these two lines, guys. X train, I am taking some numbers, and y train is truth of this, right? So here I have on one hand my independent variable, that is x. On y train is my target variable. Okay, so let me write it here. This is my feature, okay, and this is my target. Okay, feature and target defined. So my actuals are defined. Okay, my actuals are defined. Now what is next? Next is I will go ahead and I will create some test data. So I want to create the test data same as my X train, because I want to, predict using this only. So test data for feature. Done. Let's run this three. Now let me plot this and show you how it looks like. So I told you that everything will be cubed. Okay, so whatever x I give, it will be cubed. So here, as you can see, all the x's are cubed here. Okay, so minus 1.5x, this is the cube, and when 1.5 is the x, then this is the cube. So this is basically a cube function. On x is independent and y is target. Simple. Now let's come here and try to see what is happening when we are defining our model. So this part is done. Let's go to my notebook. We have defined the actuals. Now we need the predicted. Okay, so how we will do the predicted is basically we need to define a model. Okay, model is what? Model is nothing but combination of weights. So if you think of neural network, right, model is nothing but combination of weights, right? So I will go here to my notebook and I will define some weights. That becomes my model. So here define model I'm saying, and I'm defining some weights. Okay, once I have the weights, right, then I can easily predict. So I am having a predict function. If you see here, def predict weights and x it will take, and then I'm saying, if you see this line which I'm highlighting here, it is nothing but beta 0 plus beta 1 x1. Okay, so here I am saying prediction. Okay, let's go here. I have defined my predict function also. I have defined my model, my predict function. And now I will go here and I will define my loss function. So this is very simple to understand. What is a loss function? Loss function is basically difference of your actuals and predicted, right? We have defined the predict function here. So I will simply go and say ypred is equal to predict of weights and trains. So if you can see here, weights and trains is what I'm supplying here. Okay, so weights and train, if I supply, I will get a prediction, and then I can define my loss function. So this mean is what I'm trying to optimize here. Okay, this mean is what I'm trying to optimize here. Now, some of you who is not clear on loss function, you can go and search for Unfold Data Science on. Let me show you. That is actually a very uh, people say a lot of good things about that video. Loss function. So at Unfold Data Science, you will find this video, cost function versus loss function. Okay, you can watch this video. It's very simple to understand. Now, going back to our definition here, going back, what we have actuals and we have predicted and we have defined our loss function. We have defined our weights to be optimized. Now, the last thing we need is we need to run multiple iterations. Why I am doing all this hard work is I want to build a solid foundation of what I'm trying to learn. Remember, guys, if you don't get your hands dirty, you will not learn things. So I'm defining a loss function here. Now this loss function needs to be optimized. Correct? That is the only thing that happens in gradient descent, right? This loss function needs to be optimized. So first of all, if I see current situation of my fit, right? Current situation of my fit is this. So what you see, this curvy line is my actuals, and this line, orangish line, is my predicted. Okay. So as you can see here, I'm plotting the base function that I have defined above. This is my base function that I have defined above. And here I am just saying X test versus predictions, and then label is prediction of model fit. So as you can see, prediction of model fit. So this is not fitting good at all. Now what I want to do here, I want to simply go and call my gradient descent with this loss function. Now pay attention here, guys. These three lines of code are pretty important. In JAX package, right, there is a gradient descent function. So I go here and I just say jx.grad and I give my loss. Okay, what is my function that needs to be optimized? This function needs to be optimized, loss function. Okay, so I go here and I simply give loss 0, and then I run a for loop. And if you know what happens in gradient descent, then this is very, very familiar to you. Here, nothing much is happening, but new weight update is happening using your learning rate and gradient value. Okay, so as you can see here, this is your old weight, this is your old weight, and then you subtract your multiplication of your learning rate and gradient function output. Once I run this, you will see that my weights have started become optimized, and here is my loss printing. Okay, so for every 10th iteration, I think I'm printing the loss. So here you can see my loss function is coming like this. And if I want to see my optimized weight, then I can simply uncomment this and see how my losses is being optimized. Okay, so you can see my optimized losses are also optimized weights are also printing. So what did I do in this entire process, guys? I understood how this gradient descent works. In my mind, I thought, okay, for gradient descent to work, I need a loss function, I need weights to be optimized, I need to run that through a loop in iteration. But I will also need actuals, I will also need predicted, then only I can define a loss function, and then all the story continues. If you do like this, right, I'm telling you guys, you will not forget your concepts. Okay. And interview, they will grill you in all these questions. It will be a cakewalk for you. Let me show you another example. Suppose you want to learn PCA, principal component analysis. Okay. Let's go with the same funda and try to understand how to break it into piece by piece. Okay, so here let's assume that you again go to Unfold Data Science and search for PCA. In this PCA video, right, you can see nearly half an hour video. You will find all the mathematical concepts of PCA in this one video. So you can watch this video, but I'm saying you can learn from anywhere. Now you learn the concept. Now you know what PCA is. The second thing is start writing like this. I'm writing here. I know it might be boring for some people, but sometimes study is, good study is little boring. If I tell you how to do PCA, what is your step one? What is the input to the PCA? I will say take a matrix. Okay, this is my input to the PCA. What will be the step two of my PCA process? If I have learned the theory of PCA, what will be the step two of my process? Find column center. Okay. Then if I have learned PCA well, then I know that the third step is find column means. Actually, this will be means basically. Third will be center. Find column means. I am also referring to a note so that I don't miss anything important. Then comes find column centers. Okay. So center of columns you will find. And then what you are going to do? You are going to calculate covariance matrix. Calculate covariance matrix. And then what you are going to do? You are going to calculate eigenvalue and eigenvectors. Calculate eigenvalue vector or value. And then what you're going to do, you are going to project data, which means original matrix, into new space. New space means your new principal components that will become your axis. So around that you will project your data. So these are the steps I need to do. Now you need to start thinking, how can I take a matrix? How can I find column means? How can I find column centers? How can I calculate covariance? How can I calculate eigenvalue, eigenvector? And how can I project data to a new space? Let me show you that. And I'm going to refer to a very nice article by Mr. Jason Brawley. So courtesy to Mr. Jason Brawley for this article here. Machine Learning Mastery. I'm sure most of you would be aware of his blogs. Amazing blogs. Okay. So I'm referring to code given in this blog. Calculate, you know, principal component analysis from scratch. So I will come here and I will show you a few things. So whatever I wrote in the note now, right? What I'm doing, I'm defining a matrix here, as you can see. I'm printing the matrix so that you can see it. I'm finding column means. Okay, column means was the second step. Then I'm finding center columns by subtracting from column means. Once I do that, I'm calculating covariance matrix. Once I do that, I'm calculating eigenvalue and eigenvectors. Once I do that, I'm just projecting my data to the new axis. Now, again, for some of you, it might be difficult to understand. Please refer to PCA video in detail. It's a lot of mathematics here. Sometimes it may be challenging to understand. Please refer to that video. But this is nothing but all the 6 steps that we just saw. Okay, all the steps that we just saw here in the notes. That is what I am explaining you here. Now, if I go here and if I run this entire thing, right, I have defined a matrix here. If you see 2, 2, 3, 3, 5, 16. Okay, and if you have a look at these numbers, right, in the bottom part of the video, I'm using the PCA package from the Python. Okay, and I'm doing the same things. I'm just directly doing PCA, then fit, then transform. Not transform, thus fitting, and here in the end, kind of transforming to the new axis. I mean, I'm transforming my data. So here also you will see that for the same input, right? If you compare these transformed data, right? So if you compare these, let me copy it here, then you will simply see that axis is rotated. That's all. The values are same. So if you can see here 0.38, 5.16, minus 5.16, minus 0.38, okay? Minus 0.41, 3.99, minus 3.99, 0.41, 0.03, minus 9.15, 9.15, minus 0.03. So this is just about, a different direction of the axis. That's all, nothing else, okay? And both your PCA normal and Python PCA are giving you same result. But what you need to do, you need to not refer to Python packages in the beginning, otherwise your concepts will be very, very poor, and there is a high risk that you may get caught in the interview, or people will not like that your foundation is weak. Last but not the least, let me come back to my note and summarize what I have been talking through, this video. So first of all, you need to learn, remember this 4-step process, guys. Learn concepts. Now there is no end of where you can learn. You can learn through blogs, videos, or whatnot. Second is do a do a toy example. Toy example means I showed you 2 toy examples now, one for gradient descent and one for PCA on some simple data. You need to just take some simple data and do it. No, let's not make it very fancy and use some huge amount of data, etc. Do a toy example because the purpose is to improve the concept. And then in this toy example, play with numbers. Okay, play with numbers because it's all machine learning concepts, right? So for example, if I'm learning gradient descent, etc., play with learning rate, play with if I change the weight, then what happens? Play with if I change the data size, then what happens? Play with numbers. So up to these 3 things, up to these 3 steps, right? Don't touch any large data set. Don't try to do something very fancy. Don't try to get the correct output. Don't try to get the right output. Okay. The purpose here is building, building, building foundation. Okay. Once you have built this foundation, then you can do what not, right? Then you can use Python packages. Use Python packages, take a fancy data and try to build whatever you want to build. Okay, but this comes as a step 4, not as a step 1. So go like this. Okay, remember this is very, very important. So I'm not going to give you, normally I give my notebooks to people, but in this video, I'm not going to give you the notebooks that I showed you because I want you to go through the process of writing that by your hands. If you are really interested in learning something in detail, I'm sure you will do that. Okay. Please give me a thumbs up, guys. If you like this video, please drop me a comment. How did you feel about this video? See you all in the next one. Wherever you are, stay safe and take care.